Hi students, welcome to the class. In today's session, what we are going to do means we are going to think about our chain rule under derivatives. Okay students, what is the importance of chain rule? We are going to see. So basically, if we look into under chain rule, we have got four categories. The four categories are what is chain rule? Okay students, why we are learning chain rule, when to go for this chain rule, if a function is given, when to apply this chain rule, how to use this chain rule. So these are the four main categories we are going to discuss today. Okay students, by the end of this session, definitely you'll be knowing how to use this chain rule. Let's get started. Whenever you look into the question, they will be asking you find the derivative. So we need to know what is the derivative first. Okay. Yeah. Let's take a look into this. Here we have got a curve. Okay, students, we'll name this curve as f of x. And here if you look into, we have got a tangent line. This tangent line is touching the curve at one point. Am I right? So that I'm going to name as A. Why I'm calling this straight line as a tangent line? Because whenever a line touching the curve at one point, that is said to be tangent line. Okay, students? Yeah. Now, we are going to think about slope of this tangent line. So, slope of this tangent line to this curve is said to be derivative. Okay, students? So, how do we denote this? We will be denoting this as dy by dx, f dash of x, and similarly y dash. So these are the notations we are using to denote our derivative. Okay, students. Now we'll think about what is chain rule. Okay, now only we are getting into the actual picture. So what is chain rule? In simple words, it is outside, inside rule. Let me explain this to you with a formula. We are going to assume the function to be looking like this. I'm having f outside. Another function I'm going to put inside like this, inside this function. Okay, so if it's so, how to find the derivative means, first thing is we will be considering our f. So for that, we will be finding the derivative. And then we will be keeping the inside function as it is. Now only we will be looking into the inside function. For that, we will be taking the derivative. Okay, students, I'll repeat it again. What we are doing here, whatever may be the question, first thing is we are looking into our outside function. So derivative of outside only we have to do first, leaving our inside alone. Okay, we are not at all disturbing that. Okay, students. Yeah. Now we are looking into the inside function. For that, we are taking the derivative. Derivative of inside function we are doing after our outside. This is the way it works out. Okay, students. Yeah, we have answered for what? Why we are learning this? This saves time. Okay, students, time is the only thing which we never get back, because the question, whatever they are providing, will be a little bit complicated. So we can make it simpler by using this rule. That is the most important feature of this rule. Okay, students. Yeah, now we'll move on to our example, because we need to know when to go for this. Am I right? We need to know when to go for this, how to use this. So remaining two questions also we need to answer. Yeah. Usually if you look into this example, what do you observe? 3x plus 1 is there. Okay. a smaller function, I would say a x, okay, smaller x expression lying inside the larger expression, okay. Whenever we are having a group of functions nested together like this inside, we will be going for this chain rule. Okay, I'll repeat it again. A smaller expression inside a bigger expression. Okay, at that time, we will be going for this chain rule. Let's give a try for this. Now, we'll try our dy by dx. Okay, so dy by dx is, we have to look into our outside function. Here, outside function is having a power. We know that already. Finding a derivative of x power n is nothing but n comes in front and we will be reducing the power by 1. So this is the rule we are having. So this only we are going to apply now for our outside function. So the derivative of the outside function is 7. I'm going to leave my inside alone and reducing the power by 1 will be giving me 6. Okay, students. Now we will be looking into the inside function. Derivative of 3x plus 1 is simply 3. Am I right? Derivative of a constant is 0. We know that. 3x only now we can do. So that is simply 3. Okay, students? Yeah. Now, actually, we are done. So 7 times 3 will give us 21. And we can keep this one as it is. Okay, it's super cool, right? Yeah, this is the way we will be doing our problem. Okay, students, now you got the idea how to approach this. Am I right? Yes. Let's play a game. Okay, students? Yeah. What kind of game means? You will be finding out whether it's a chain rule or not a chain rule. Okay. Yes. Take a look into this one. They're asking us to figure out derivative. Okay. Yeah. Okay, students. So finding the derivative for this, do we apply chain rule? Actually, no need. Am I right? It's a straightforward question. We are not having a smaller expression lying inside a larger expression. It's a normal expression. Okay. So no need for this. We'll think about the next one. Take a look into this. Do we need the chain rule for this one? It's so simple. X power 9, we know how to find the derivative using power rule itself. So no need for this. Take a look into this one. Is this a chain rule stuff? Of course, yes. Okay, students, y means here we have got a smaller expression, x expression lying inside a larger expression, which is power of 9. So we need chain rule for this. Okay, take a look into the next one. What we have to apply for this? Do we need a chain rule? Yes, of course we need, because here also the same smaller expression x squared plus 5 minus 6 is lying inside a larger expression like this. Am I right? Yes, we need our chain rule. Okay, one more final example I want to show you. Take a look into this. What we can say about this? We have discussed that a smaller function lying inside a larger function. Am I right? Then which is a smaller function here? Our x square, in place of angle, we have got x square. It's lying inside a bigger function. That is nothing but our trigonometric function sine. So we need a chain rule for this. Okay, students. Hope you all got the idea how it works. I hope you understood the lesson, how we have to go for this, what is chain rule, why we are learning, when to go for this rule. Am I right, students? Thank you, students. Have a great day. Stay safe, stay blessed. Thank you. Take care.
Manorama Horizon. Learning made simple.